Okay, so our first video assignment calls for the construction of the following figure. The figure you see here is just a rough estimate of what this figure should look like when we're done, but this one specifically was not used or constructed using a compass or a straight edge, and is only present to highlight the details of the exact figure that's about to be constructed using those tools. So the figure about to be constructed is kind of a house shape, and all sides are of unit length. It's basically a square with an equilateral triangle protruding from one of the sides. And we also know, and it is given in the instructions, that these angles here, alpha and beta, are each 150 degrees. So we have to construct this figure using the exact geometric tools of a compass and straight edge. So we'll begin by getting first sheet of paper, a new plane, I guess, and defining 2 points in this plane, A and B. We'll label them A and B. And we'll connect them with a line segment using our straight edge. So this length AB we will define as our unit length, and it will be the length that we're going to be duplicating throughout the figure. So after this, we will extend this line segment AB past B, and this extension really won't be part of the final figure, but it'll be more of kind of a helping line, an auxiliary line that will help us create our perpendiculars. But we'll get to that later, but first we'll extend it like I said, and just to drive home the point it's not part of the final figure, I'll make it a dashed line. And it can go to any distance, we won't really need that much. So the next steps collectively, like I said, will construct a perpendicular from B to a newly created point C above B. So with our compass set to any radius and centered at B, we will create 2 intersections with AB, or more specifically AB and its extension to the right of B. So we'll do that now. Oops, wrong way. Just try to get it centered here, and the intersection to the left, and an intersection to the right. Okay, so using the same or a different compass radius, we will make 2 arcs centered at these intersections that meet above B, and this radius has to be the same for both arcs. So we'll center it at the right intersection first. Once again, this arbitrary compass radius right there and right there, centered at the left and centered at the right, and we have an intersection point. And this line, or this intersection point, is above B, and we will drop a perpendicular to B from this point. And this line is not necessarily AB, although it kind of looks like it, but we can't assume that. And we will do further steps to ensure that is of length AB, but we can't assume that now. But this line is perpendicular. That is one thing we can assume is true. Now we must set our compass length to an exact length finally, and that length will be of AB, so we'll do that now. Okay, so I got that saved, I guess, saved in the compass, and we will create an arc above point A. So kind of in this general area here. And we will do the exact same thing with the compass with radius AB centered at B, and we'll make another arc above B. Okay, so first the arc we made above B intersected that perpendicular we just created, and this we will actually label this intersection point. We'll do it point C, like I said, and this length will actually be exactly the same as this length, so we can safely and confidently say this is of the unit length AB, this BC length. And next, the we will now with our compass centered at C, And again, with the same stored radius AB, we will create an arc to the left such that an intersection is created with the arc we made above A. And we'll label this point D. So again, with a compass of radius AB and centered at C, we will make an arc to the left, like I said, so that it intersects the arc we made above A. Okay, and we'll label this D, like I said. So this intersection here of these two arcs we'll label D. So now we can connect A to D and D to C if we'd like. So we'll do that. We'll drop that perpendicular from D to A, and again we can confidently say that that is of the unit length AB. And I know our final figure doesn't have a line here, so I'll put a dash line. It'll kind of be used to prove sort of a point later, but it's not really part of the final figure. Okay, so AD, DC, BC, and AB are all of the unit length. But our figure is not completely done, because we know that the final construction had kind of an equilateral triangle protruding from one of the sides. So to do that, we'll choose a side. We'll just make it the top one, this DC line that's not really going to be there in our final construction, and say that we want an equilateral triangle to protrude from it. And that construction is much simpler. So again, with the radius stored in our compass, AB, we will center an arc at C and make an arc here. And then we will do the same thing, compass stored with radius AB, centered at D. These 2 points, or 2 arcs I should say, have an intersection point. I guess we'll call it E. And if we connect D to E and C to E, we actually have made an equilateral triangle. So I'll do that real quick. Alright, and we can actually confidently say that these are also of unit length. DE and CE are of unit length. And that actually completes our construction. So you also might be asking, well, why? It looks like the figure that we presented in the beginning, but how do we know that these angles right here, because remember they were said to be 150 degrees, how do we know they're 150 degrees? Well, we are confident using our construction that we constructed a square here. Perpendiculars all around every side, perpendicular to the next. So we can confidently say that this line, this dashed line to the segment BC, and the same thing over here, this dashed line to the segment AD is 90 degrees. And up here, this equilateral triangle we created, the dashed line to segment CE and the dashed line to segment DE will be 60 degrees. So just adding those angles, 90 plus 60, could be 150 degrees. So we can confidently say that we constructed the figure, and using the exact tools of geometry, a compass, and straight edge, with all sides of unit length, and with angles alpha and beta being 150 degrees. So I think that completes the assignment.